GREP, a physics-based recommendation as a service, RAS. GREP, a physics-based approach to recommendation systems. Introduction. In a world dominated by AI-powered recommendation engines, from e-commerce to streaming platforms, the traditional model often relies on black box algorithms. These systems are powerful but come with significant downsides. They're opaque, computationally expensive, and often inaccessible to those without specialized expertise. Enter the Gravitas Recommendation Engine Protocol GREP, a revolutionary system rooted in physics rather than AI. GREP leverages the foundational principles of gravitational averaging (GA) and dark matter, inspired mechanics to deliver fast, customizable, and transparent recommendations. It doesn't just recommend, it enables art-directable recommendation systems, where users can tailor outcomes using intuitive parameters, bypassing the need for complex machine learning models. In this article, we'll explore the foundations of GREP in gravitational averaging, the working visualization of GREP for multi-process recommendation systems, how GREP lowers the barrier to entry for recommendation services, the foundations, gravitational averaging, and dark matter mechanics. At its core, GREP is inspired by the dynamics of dark matter filaments and gravitational forces that organize the universe. These phenomena mimic neural pathways in a way that feels both intuitive and profound. Here's how GREP's physics-based principles work. Mass as importance. In GREP, mass represents a data point's importance or compatibility, dynamically calculated using a configurable schema. For example, in a dating app scenario, mass might combine attributes like proximity, age difference, and relationship priorities. 2. Gravity as affinity. Just as gravity pulls objects together, GREP's simulated forces attract dynamic nodes (DNS) to primary mass nodes (PMNs). This creates a natural clustering effect, where high affinity matches emerge dynamically. 3. Smart randomness. GREP doesn't rely on hard-coded rules. Instead, the system's behavior emerges naturally from the interplay of forces, creating a stochastic yet purposeful recommendation process. This physics-based approach avoids the pitfalls of AI, such as opacity and retraining requirements, while delivering recommendations that feel intuitive and explainable. A working visualization, multi-process recommendation. One of the most exciting aspects of GREP is its real-time visualization. Below, we outline how the current system operates in a multi-process recommendation context. Dynamic nodes (DNS) represent individual data points, e.g. users' items. Their attributes, e.g. render time memory, are configured via a schema to calculate mass scores dynamically. DNS are visualized as orbiting entities, influenced by gravitational forces exerted by PMNs. 2. Primary mass nodes (PMNs) act as processing hubs, e.g. servers, queues, or recommendations. PMNs attract DNS based on configurable parameters, processing them in either single-process or multi-process modes. 3. Multi-process efficiency. In multi-process mode, PMNs can handle multiple DNS simultaneously, dynamically adjusting capacity based on configurable thresholds. The system's gravity ensures DNs are not only matched efficiently, but also visually represented as they cluster and disperse based on their scores. This visualization isn't just a debugging tool, it's a testament to GREP's real-time, physics-driven logic, providing clarity and transparency at every step, lowering the barrier to entry for recommendation systems. Traditional AI-powered recommendation engines are resource-intensive and often require a team of data scientists to fine-tune models. GREP changes the game by configurable schema. With GREP, all attributes, weights, and thresholds are defined in a simple configuration file. This enables rapid customization for different use cases, e.g. dating apps, job queues, fine-tuned control over recommendation logic without writing a single line of code. 2. Explainability. Unlike AI, GREP is inherently transparent. The mass, proximity, and gravitational forces driving recommendations can be visualized and adjusted in real time. This makes it easy for stakeholders to diagnose and improve system behavior. 3. Efficiency. By avoiding the computational overhead of neural networks, GREP delivers recommendations at a fraction of the cost and time. Even with vast datasets, the system can prioritize and render only the most relevant data points, further enhancing performance. 4. Art-directable recommendations. GREP empowers product designers and decision-makers to craft bespoke recommendation experiences, aligning with brand values or creative goals. For example, a media platform could prioritize diversity in recommendations by tweaking attribute weights, all without relying on opaque algorithms. GREP versus traditional AI solutions. While GREP isn't an AI system, it's capable of competing and even outperforming AI in many contexts. Here's how it stacks up. GREP, a SaaS opportunity. GREP isn't just a tool, it's a platform, a recommendation as a service RaaS solution that could disrupt industries by democratizing recommendations, enabling startups, small businesses, and non-technical teams to implement high-quality recommendation systems without AI expertise. 2. Competing on speed and scalability. GREP's real-time processing and configurability make it ideal for fast-evolving industries like e-commerce, dating, and media. 3. Complementing AI. GREP can serve as a bridge for businesses hesitant to adopt full-fledged AI solutions, offering a transparent and cost-effective alternative. Conclusion. The Gravitas Recommendation Engine Protocol GREP represents a new paradigm in recommendation systems. By leveraging physics-inspired dynamics, GREP delivers transparent, efficient, and highly customizable recommendations that lower the barrier to entry for businesses of all sizes. In a world where AI often feels like a black box, GREP's art-directable framework puts control back into the hands of creators, empowering them to design systems that align with their vision. Whether as a standalone solution or a stepping stone to gravitational averaging, GREP is poised to redefine what recommendation systems can be. It's not just a tool, it's a protocol for the future,